So our next chapter is instruction set of 8085. This is very important chapter because this chapter is a heart of CS2. Okay, so you have to understand all the concept regarding with this chapter because during practical session we have to know about the each and every instructions for performing a program. So all your CS2 part is depend on instruction set of 8085. So what is instruction? An instruction is a binary pattern designed inside a microprocessor to perform a specific function. So instruction are given to a microprocessor for performing a specific functions. For after giving a instruction, it can perform any functions like subtraction, addition, multiplication, division, etc. Okay, so it requires a instructions, then according to that it performs a functions. The entire group of instructions that microprocessor support is called as instruction set. So that the various instructions for performing 8085 is combinedly called instructions set. So 8085 has 246 instructions, that is 246 instructions, and each instruction is represented by an 8-bit binary value. So 8-bit binary value consists of opcode and instruction byte. Opcode means move, LXI, LDA. So these include opcode, and instructions it contains operand also, means it may be data, address, etc. Okay, so this is a instruction set of 8085. See the next slide. Classification of instruction set according to the different addressing mode. It depends, the instruction sets are divided into following parts, that is a data transfer instructions, arithmetic instructions, logical instructions, branching instructions, and control instructions. So these are the 5 instructions in a 8085. Means we can, if you want to transfer a data, then we use data transfer instruction. If you perform arithmetic operations like addition, subtraction, then there is arithmetic instructions, logical instructions for AND or XOR. Okay, branching, jump, and all. Okay, let's see one by one. So first one is a data transfer instruction. These instructions move data between register or between memory and register. So these instructions, if you want to move the data between register and memory, we use data transfer instruction. These instructions copy data from source to destinations. Okay, we will in next slide we will see the examples also. So while copying, the contents of source are not modified. So for copying a content of one source to destination, these data transfer instructions are used. If you want to copy the data between register and memory, then we will use data transfer instructions. See here is a opcode, that is MOV, operand is RD, it may be register. Okay, then it may be memory, then it copies content of source to destination. So see here, these instructions copies the content of the source register into the destination. RD means register destination, RS matlab register source. Okay, so the contents of the source register are not altered. It copy the content to the destination, but contents of the source register are not altered. It cannot be modified or it cannot be changed, it still remains same. If one of the operand is a memory location, its location is specified by the contents of HL register. Whenever HL register memory comes, it points to the HL register. So you have to remember, whenever memory comes, its pointed to the HL register. Okay, see here, move B, C means it copies the content of C to P. Okay, so C is a destination, C is a source and B is a destination, and move B, M means here is a memory is a source and destination is B. Okay, means see here format is MOV move RD comma RS means destination and source. Okay, so this is a data transfer instruction, that is move instructions. So next see, then MVI, the second data transfer instruction is a MVI means move immediate 8-bit data to a destination. It will be register or it will be memory. Okay, so the 8-bit data is stored in the destination register or memory. If the operand is a memory location, its location is specified the contents of HL register. So whenever memory comes, it points to the HL register. See the examples, MVIB comma 57H. So 57H data is immediately moved to the B register. Okay, and MVI comma M means comma 57H, this is a data, 57H is a data which immediately move into the memory. So this is a MVI instructions, that is data transfer instructions. So first we see move instruction, then next is a MVI, then third one data transfer instruction is a LDA means load accumulator. It contains 60-bit address. Okay, 60-bit address. See here, the contents of the memory location specified by 60-bit address in the operand are copied to the accumulator. So that 60-bit address is copied to the accumulator. See here, LDA example, LDA. So LDA is a operand and here is a 60-bit address 2034. So this is a 16-bit address. Okay, 20 and 34. So this is a 16-bit, 8-bit plus 8-bit, that is 16-bit. So this is a LDA instructions, load accumulator. Then next instruction is LDAX means load accumulator indirect. Whenever X comes, it always comes with a pair. Okay, so you have to remember that whenever X comes, it always comes with a pair. See here, the contents of the destination register pair are point to a memory location. This instruction copies the content of the memory location into the accumulator. Okay, so it copies the content of the memory location into a accumulator. The contents of either the register pair or the memory location are not altered. Means while copying a data from source to destination, the destination content will not be changed. It remains, the source content will not be changed. It remains same. See here, LDAXB. Okay, so it load the content to the accumulator. B means it always comes with a pair. So next instruction is LXI. See, LXI means register pair 60-bit data operand. Opcode is LXI and operand is register pair 60-bit data. Load register pair immediate. This instructions load 60-bit data in register pair. For example, LXIH 2034. So this is your 16-bit data. So that 16-bit data is moved immediately to the register pair HL. So this is a LXI instructions. Load register pair immediate. Then next data transfer instruction is LHLD. The operand is again 60-bit address and it load the HL register direct. Okay, so these instructions copies the content of memory location pointed out by 16-bit address into register L. It copies the address 16-bit address into L registers. It copies the content of memory location into register H. Okay, so LHLD 2040. It copies the contents of memory location pointed out by 16-bit address into register L and it copies the content of next memory location into register H. So this is a LHLD instruction. Then next is a STE. This is a very important instruction, that is a store accumulator direct. We can store the accumulator direct form. The contents of the accumulator are copied into the memory location specified the operand, that is STA2500H. We can also use 8-bit data also. Here we are I have given the 16-bit, but you can also use 8-bit data, that is STA2500H. It stores the accumulator, it stores the direct data, that is this is a 16-bit address into the accumulator. So this is a data transfer instruction. Then next data transfer instruction is STAX, store accumulator indirect. The content of the accumulator are copied into the memory location specified the contents of the register pair. So example is STAXB. X means it always comes with a pair. How many pairs of register? B, C, D, E, H, L. Okay, so these are the registers, means register pair. Then next data transfer instruction is SHLD. The content of register L are stored into a memory location specified the 16-bit address. The contents of register H are stored into the next memory location, that is a SHLD 2550. So next location will be 2551. So the contents are of register H are stored into the next location and L's are stored into the memory location specified by the 16-bit address. So 2550, at 2550 it stores L, and to the next location, that is H 2551, it stores the content of H. Okay, understand? So this is a SHLD instruction. Then next data transfer instruction is XCHG, that is exchange HL with DE. So what happened in this instruction? The content of register H are exchanged with the content of register D. If you want to exchange the content of H register to D or L to E, then we use exchange instruction. Okay. Then next instruction is data transfer instruction is SPHL. See, SPHL, this instruction loads the content of HL pair into SP, means whatever data which are present in HL pair, it's directly load into the SP, that is SPHL. Then next data transfer instruction is XTHL. XTHL means exchange HL with top of stacks. So the contents of L register are exchanged with the location pointed out by the content of SP. So the content of H register are exchanged with the next location, that is SP plus 1. So the H registers contents are exchanged with which location? That is stack, top of the stack plus 1, that is XTHL. So this is an example, XTHL. Okay. So the next data transfer instruction is PCHL, means load program counter with HL content. So what will be happen here? The contents of register H and L are copied into the program counter. So your content will be copied into the program counter. Okay, so the contents of H are placed at the high order byte and the contents of L as a lower order byte. I already told you what is lower byte, what is a higher byte in our previous lectures. So go through it so you can understand easily. So example is PCHL. So this is a PCHL data transfer instruction. So next is push instructions. So push, the content of register pair copied onto the stack and SP is decremented and the contents of higher order register, that is B, D, H, A are copied into the stack, and SP is again decremented and the contents of low order, that is C, E, L flags are copied into the stack. So this example of this instruction is a push B. Okay. So this is a simple data transfer instruction. Then pop, push means it added the content and pop means it deleting. Okay. The pop register pair pop up a stack of register pair. The contents of the top of a stack are copied into the register pair, and the contents of a location pointed out by SP are copied to the lower order byte, that is CEL flags, and SP is incremented and the contents of location are copied to the higher order register, that is BDHA. For example, pop H. Okay. Then next data transfer instruction is out. It contains 8-bit operand, that is 8-bit port address. It description means what is a function of this instruction is that copy data from accumulator to a port with the 8-bit address. So it copies the data from accumulator to port with the 8-bit address. The contents of accumulator are copied into the IO port. See here example, out 78H. So content of accumulator is transferred to this port, that is out 78H. Then in and out, opposite instructions is there. These instructions, it contains 8-bit port address. Copy data to accumulator from port with 8-bit address. The content of IO port are copied into the accumulator. Example, INHCH. So the content of IO port are copied into the accumulator. In previous, accumulator content will be copied into the output port. Here input port content copied into the accumulator. So this is a difference. So I have made this PPT with which containing short points or short instructions, so you can easily remember in your books. It will be very difficult to you to understand, so that's why this PPT help you very much. And I already given you a notes, that is PDF format notes. You can refer that notes also. Okay. Okay, so this is our data transfer instructions. Understand all data transfer instructions. In next lecture we will see the arithmetic instructions.